Okay, this is a video on lesson 1.3, which is algebraic expressions. Simply stated, but really what we're going to be doing is taking factoring and expansion problems that you did in Algebra 2, and we are going to make them more challenging. So, for example, in Algebra 2, you multiplied expressions like this one. And you're probably looking at this and can recognize a binomial times a binomial means you're going to FOIL. And I won't go through this in much detail, but of course 6x times 6x is 36x squared. The outer term, the inner term, and your last term, and then you combine the middle terms to negative 60x, right? So something you're familiar with, okay? Now you're going to be doing harder questions. So if you look at the 3 examples that are on the smartboard right now, on this lesson, they are exactly what I just did, except your exponents are now rational, like fractional, or you have a radical within your binomial, okay? But think about what you do with the easier questions and apply it to the harder questions. So on the first example, you're multiplying, so FOILing the first term times the first term. Well, when you take x times x, just ask yourself, what do I do with those exponents? Well, x times x is x squared, which means I'm adding the exponents. So x to the 5 halves times another x to the 5 halves. If you add the exponents, you get x to the 10 halves, right? Which of course is 5. I'll change that momentarily. Then you do your outer, so that's going to be minus x 5 halves y 5 halves, and then your inner is plus x 5 halves y 5 halves. You can already see these are going to cancel out, right? And then your outer is going to be a minus y times y, you add the exponents, so 5 halves plus 5 halves is another 10 halves. And then make that simpler, 10 halves is really 5, 10 halves is really 5, and there's your final expansion. So it's really not as scary as it might first appear. Okay, second example, same thing. I'm going to FOIL 1 times 1. My outer is a 1 of those radicals. My inner is a minus 1 of those radicals. So again, these are going to cancel out, right? And then the last terms are going to be minus, while a square root times a square root will cancel out. So it's just minus an x squared minus 1. And I put that in parentheses because of this subtraction. So let me make that a little neater. I have 1, the middle terms cancel out, minus this quantity, which is really 1 minus x squared plus 1, right? Negative, negative. So my final answer is negative x squared plus 2 there. Okay, and then the last one, again, similar idea, just FOILing that out, right? Binomial, binomial, so 2 times 2 is 4, 2 times x to the 1/3, 2 times x to the 5/3, and then an x times an x. You add the exponents, so 5/3 plus 1/3 is 6/3. And then we can simplify a little bit. Of course, 6/3 is 2. So this is really, and then look at these. Can you combine those? Now you're adding, right? And they are not like terms because these exponents are different. So no, I cannot combine those. So I'm really just rewriting everything. And then that last term is just x squared. So there you have it, right? Stuff you know, just a little bit more thought-provoking. You might see trinomials instead of binomials. I'm not going to go through this one, but you would, same thing, right? I'm taking a times a, A times negative B, A times negative C, and then B times A, B times B, B times C, and then finally C, blah, blah, blah. So same process, is just longer, and combine your like terms, etc. You can check out the completed smartboard if you want to see that one in more detail. Okay, so now we're going to go into factoring. So quick refresher from Algebra 2. When you factor something, step 1, factor out any monomials. So looking at this first example, between 4, 10, and 24, I could factor out a 2. And then looking at your x's, 4 of them, 3 of them, 2 of them, I can factor out x squared. I'm going to stop there for just a second. Why x squared? Because the most I can take out is 2, because that's the smallest. And why am I pointing this out? Because the factoring is going to get way harder. Okay, so I'm making you think about what you're doing. So when you factor out terms, you're taking out the least common multiple, which is 2. And then when you factor out, what are you really doing? Actually, I'm going to move these down as well. What are you really doing when you factor? And you maybe don't even think about this, but you're really dividing everything by what your so when we say factor out, we're dividing, right? And so I'm left here, I'm left with 2x squared. This term is a 5x, and this term is a 12. Okay, now when you divide, also think about your exponents. You're subtracting, like 3 minus 2 to get the 1. Okay, I'm pointing out again the easy stuff. And then you might be able to factor further. Like, is this quadratic here factorable? So, and if this is like, oh my gosh, I don't remember how to factor it, that's a whole different issue. Like, we need to be talking about that, because you should be comfortable with basic quadratic factoring at this point. So factors of 12, let's see, could be maybe 4 and 3. So this could be a negative and a positive, and that's your final factor, right? Okay, so the second one I'm going to skip, but it would be the same idea, you know, like how many, I'm going to go through it quickly, sorry. How many x's can you take out? 3. How many n's at most? 1. Nothing in common between 49 and 25. So that's going to leave me, if I'm dividing, with 49x squared minus 25n squared. And now I have a difference of 2 perfect squares. So that factors down to 7x minus 5n and 7x plus 5n. So quick refresher on those. Okay, now we're going to make it harder. We're going to bring in rational exponents, well, all sorts of stuff. I'll start with that. So looking at this first example, what can you factor out? So again, think back to simple, simple, simple. If I have 7/3 and I have a 1/3, what's the most I can take out? Now remember, the most is actually the smaller amount. So 1/3 is smaller than 7/3, which means I can factor out x to the 1/3. Okay, so stop the video and write this down if you're like, oh yeah, I never really thought about it. So the most you can factor out is the smaller exponent. And then when you factor out, what are you really doing with the exponents? You're subtracting them, right? So when I factor out from this one, 7/3 minus 1/3 is 6/3, which of course is squared. And then 1/3 minus 1/3, that's gone, right? Well, is 0. Next to the zeros is 1. So now this is x squared minus 25, and now it's easy, easy, easy. That's a difference of squares again, and there you have it. Okay, so pause the video, see if you can start the next example. Okay, so I can take a 3 out of 3, 15, and 18. How many x's can I take out? Well, the smallest exponent is the -1/2, because -1/2 is smaller than 1/2 and 3/2. Okay, and by take out, by factor out, I mean I'm going to subtract the exponents. So factor out a 3, that's gone. 3 halves minus a negative 1/2 is really 3 halves plus 1/2. So that's going to be 4 halves. Okay, 15 divided by 3 is 5. X to the 1/2 minus a negative 1/2 is really 1/2 plus 1/2. So that's x to the first. 18 divided by 3 is 6. Negative 1/2 minus a negative 1/2 is really negative 1/2 plus 1/2. So that one is gone. Okay, so this is really x squared minus 5x plus 6. And again, that factors down to x minus 3 and x minus 2. And that's your final factoring. Hopefully this is kind of starting to click. Okay, the last example, little bit different, right? So I want you to see if you can see that this is the first term, because that's one big product, right? And this is the second term. So I got 2 terms. It's a binomial. What do the first 2 terms share in common? They both have a 3 minus x binomial in them. Okay, the first term has negative 2/3 power, and the other one has a 1/3 power. What is smaller, negative 2/3 or positive 1/3? Obviously the negative. Okay, so take your time with this. I'm going to factor out a binomial instead of a monomial, a 3 minus x to the negative 2/3. Okay, and remember, when you factor out, you subtract the exponents. So going back up here, negative 2/3 minus a negative 2/3 is really negative 2/3 plus 2/3. So that's gone, but I have this x there. So that's all that's left. Okay, then I have a 1/3 plus 2/3, right? 1/3 minus a negative is plus. So 1/3 plus 2/3 is really 3/3. So that quantity is then just raised to the first power, which I don't need to write the 1 there. Okay, so I'm just going to erase that, but just to clarify. All right, and then, so I factored this out, and then left in the brackets, if I distribute that negative through, I'm really going to have a 2x minus 3, and that's the factoring. Okay, and I make this sound easy. Those are tricky questions. All right, more factoring. So I'm going to give you a second to look at this one again. Looks a little different. Well, both of them. Take a peek at both of them. And when you see this, it's not hard. But when you don't see that it's really just a quadratic, it can be challenging. So first thing, if you were thinking, oh, I can FOIL this quantity, right? And absolutely you can. And I could distribute that -6 through. Yes, you can. Okay, but that's a whole lot of work, but you definitely can do that. So don't forget about the long route. I'm going to teach you a shortcut. Okay, I'm going to say, let's let A equal that 2x plus 3. So that means this is really A squared. This is really minus 6A, and then minus 16. So I did a little substitution, if that's okay. I'll come back to that 2x plus 3. Well, now this is just an easy quadratic to factor. This is really going to factor down to A minus 8 and A plus 2, right? But then don't forget, A is actually just a substitute right now. So now I need to go back up here and plug in 2x plus 3 back in for my A's. So my A's are back to 2x plus 3. And then simplify those a bit. Of course, you can combine your like terms. And you got it. So that's an option. Okay, and some of you might not even need to do that. Some of you might be able to go back to the original question here and just note, oh, of course, that's a quadratic, but instead of like an x squared, it's a binomial, 2x plus 3, quantity squared. That's great. If you want to bypass the substitution, totally fine. So for example, in example 2, or the second example, if I just kind of bypass the substitution game, I can see that this is a difference of squares. So I know that this is going to factor down to a plus b plus c and a plus b minus c. Okay, and if you don't see that, go back to the shortcut. So let's call this x squared minus c squared. And then that's going to factor to x plus c and x minus c. But what is x? X is really a plus b. So go ahead and look at it that way if you would like. All right, moving on then to sum and difference of cubes. This might be new. Okay, so I will tell you this first of all. The formulas up here, sum of cubes and difference of cubes, these obviously write down. You do not need to memorize those, right? Because you can pull up those formulas if you need them on a test. You'll just need to be able to recognize them. Okay, so I'm assuming you're okay with cubes, like 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, etc., etc. I won't get too carried away. Okay, so if you have a factoring question that happens to be the sum or difference of 2 perfect cubes, you can use this shortcut. Okay, A and B are generic, so A and B represent numbers that are being cubed, or variables, of course, that are being cubed. So for example, if A is 3, then A cubed is 27. Okay, so that I'm sure is probably self-explanatory. So if you look at the first example, 8x cubed is a perfect cube because 2 cubed is 8 and x cubed is a cube, right? So if I just rewrite that like 2x quantity cubed, that's the same thing. And then y cubed clearly is already a perfect cube as well. So I'm just going to kind of separate those, right? So why did I do that? Because I just want to make sure you see now that A is really 2x and B is really y. So you don't actually use the 8x cubed, you use the quantity that creates that perfect cube, the 2x and the y. So now that let me clarify that even better. Now that I know my A is 2x and my B is y, and this is a sum, I'm going to go back up to my sum formula, and I'm literally just going to plug in the variables. Okay, so A plus B, A is 2x, B is y. That's my first chunk. Second chunk is this, A squared minus AB plus B squared. Okay, so my A squared, be really careful here, 2x quantity squared is a 4x squared, minus AB minus 2xy, and then plus B squared, y squared. And that's it. The quadratic piece, by the way, will never factor down further, I promise you. So this is your final answer. And it's not that bad if you get it, because it won't factor down any further. Okay, I'll do one more, just to make sure you're good with this. So if you look at this example, 2 is not a perfect cube. 54 is not a perfect cube. But you can factor a 2 out, right? And then this is x cubed minus 27y cubed, and now we got perfect cubes. Okay, so now I'm doing subtraction, so this is a difference. So I'm going to follow the difference formula. Why don't I just erase all my lines up here so that's not so wild and crazy, but now I'm following this one here. Okay, A is going to be x because that's what I'm cubing, and B is going to be a 3y because 3 cubed is 27, y cubed is y cubed. So there you have it. And then the 2 I pulled out, of course, needs to stay there. So following this, A minus B is x minus 3y. A squared, again, always be careful, A squared is x squared, well, that's pretty self-explanatory, plus AB is plus 3xy, and plus B squared, that one you gotta be careful of, you're squaring that whole thing, so 9y squared, and that's it. All right, on to the last type of factoring, and I think you maybe did this one in Algebra 2. Well, I guess we'll find out, we'll jog your memory. It's actually not, it's probably one of the easier methods anyhow. So factor by grouping is only used when you have an even amount of terms. So notice I have 4 terms here. I can't group with 5 terms or 7 terms. Okay, and what you do is, and you can rearrange them if you need to, but if I group the first two terms together and I group the second two terms together and kind of separate them momentarily. So look at the first two terms. What can you factor out of 4x to the fourth and 8x cubed? Well, I can factor out a 4, and I can factor out an x cubed. Okay, so do that. That leaves us with x minus 2. Okay, what can you factor out of the second grouping? Well, what can I take out of 24 and 48? I can take out a 24. X squared and x, I can take out an x, and then I'm going to do that. So that will leave me with x minus 2. Okay, so I really just kind of separated this into two separate problems, right? And now the point of grouping is look at this binomial here, and this binomial here. What do they have in common? The x minus 2. Well, okay, if I factor out the x minus 2, so remember, when you factor out something, you subtract it out. So if I factor out the x minus 2 here, I'm left with 4x cubed. If I factor out the x minus 2 here, I'm left with 24x. And I'm almost done. I hope that you catch that I can take out a 4 from here, right? And I can take out an x. And so that will leave us with 6x, oh sorry, not 6, that's the second piece, not to confuse you. That will leave us with x squared plus 6. And you might say, well, couldn't I have taken out a 4 and an x at the very first step? Absolutely, yes, you could. So whatever you prefer. And that's grouping. So basically chunk the first two, chunk the second two. The common binomial that you're left with is here, and the stuff you pulled out front is here, right? You might see a little theme. Okay, one more, just a fun challenge to kind of put a bunch of ideas together here. Whew, a lot going on in this one anyhow. So looking at all this stuff, okay, first of all, it's a binomial. This is one first term, this is the second term of the binomial, okay? What can you factor out of both? Start with the easy numbers. The non-variables, that is, right? So I got a 6, and I have a 1/2, okay? What can you factor out? Well, now think about if it was a 6 and a 12, you'd factor out a 6. Why? Because it's smaller. So between 6 and 1/2, 1/2 is smaller, okay? So I'm gonna factor out a 1/2. And I'll come, actually, no, I'll do, you know what, I'll do this step by step. You don't have to do this step by step. That's gonna get long. Okay, so if I factor out a 1/2, well, when you factor out, what are you doing? You're dividing. So 6 divided by a 1/2 is 12. Be careful. Remember, when you divide by half, you're multiplying by the reciprocal. Okay, and then I'm gonna rewrite all this craziness. When you feel comfortable with this, I would not break this into steps. It's gonna take a long time. Okay, the next binomial, well, 1/2 divided by 1/2, that's gone. Hopefully that's easy enough for you to see, right? So I just factored out 1/2. Okay, well, now go back to the binomial here, and here. What else do they share in common? Well, they share a 2x minus 1, and they share an x plus 3. Okay, here, I think I'll just do them both at once, because they're both binomials, so it's really the same exact idea. So, okay, 2x minus 1, I have it squared, and I have it cubed. So the most I can take out is 2, because 2 is smaller than 3. So I'm gonna factor out a 2x minus 1 squared. Okay, now look at your x plus 3's. I have a 1/2 power and a negative 1/2 power. Negative 1/2 is smaller, so I'm going to factor out x plus 3 to the negative 1/2. Right? Just taking out, factoring out, which means the smaller exponent. All right, well, what's left? So going back to here, if I factor out, I have a square, and I'm taking out a square, so that's gone. I have a 1/2 power, and I'm taking out a negative 1/2. Remember, you're subtracting, so 1/2 minus a negative is really plus, and 1/2 plus 1/2 is 1. So I'm going to have an x plus 3 to the first power left. I'm not going to write to the first power. Okay, going on to the second part of the binomial, I have a third power, and I'm taking out a second power. So 3 minus 2 is 1, so I've got a 2x minus 1 left to the first power, and then I've got a negative 1/2 power, and I'm taking out a negative 1/2 power, so that's gone. And then I just gotta simply, oh, I make that sound so easy, simply combine my like terms here in my final big parentheses. So x plus 2x, 3x, 3 minus 1 is plus 2, and there you have it, your final factoring. Whew, good stuff, huh? All right, well, there you have it, and I hope that you enjoy this challenging section.